So here we have a quadratic function, but it's not in the form, a times x minus h squared plus k form. They want us to write it in that form. And we do it by completing the square, which we've completed the square in the past to solve quadratic equations, but it's a little bit different here. I mean, the concept's basically the same, but it's going to be a little bit different. Okay. So because we don't have an equation that equals a value, we have a function. Okay, so we're going to rewrite it. F of x equals negative 4x squared minus 8x plus 1. Yeah. If there is a coefficient other than 1 on x squared, you have to factor that out. Now, what we're going to do is we're going to take these two terms, kind of push the 1, the constant, down toward the end. All right, so I'm going to take out the negative 4. That's going to give me x squared plus 2x, leave a little space, plus 1. Okay, so the question is, do you see where everything's coming from? I factored out a negative 4 there. So if I were to multiply that in, I'd have the negative 4x squared, and then I'd have a negative 8x right there. Okay? The 1 is kind of out of the picture right now. So if you're feeling bad for the 1, don't feel bad for the 1. Okay. Now what we're going to do is we're going to complete the square for this part right there. So you're going to take, we have x squared plus bx plus, and then we're trying to figure out what would go there to make it, bx. And what do we need to put there? So you're going to take the 2, that's your b, take the 2, divide it by 2, and square it. That's how we complete the square. You take that coefficient b, divide it by 2, and square it. So in this case, we get 1 squared, which is 1. That means we need to add a 1 plus 1 right there. Now, this stuff in parentheses, that's going to be a perfect square trinomial, and we're going to be able to factor that into something squared. That's great. Okay, but you don't get to just put a 1 in there because you want to. You want the 1, because that's what's going to complete the square. But you have to counteract it so that it's not affecting the equation. So what we do is we take the 1 times negative 4. Now, that's because you really didn't add a 1, you really added a negative 4. So what's the opposite of adding a negative 4? Adding a positive 4. Okay? Now, if you were to multiply that out, you'd get back the original function that you have. Okay? So think about if you distributed the negative 4, you'd get the negative 4x squared, you'd get the negative 2x. Then you'd have a negative 4 from this part right here, but that negative 4 would add to this positive 4, which would be 0, and so you didn't change the function. Okay? So that's the tricky part. Complete the square, and then you have to kind of counteract it. All right. You can look at the book. They might have a different way of explaining it. All right, now I'm going to write it in that fabulous form. I've got negative 4. Then I'm going to factor this because it's a perfect square trinomial. So it factors into x plus 1 squared. Remember, I'm taking the square root of this, or I'm taking, this number right here. It just happens to be a 1 this time, plus 5. And now I have it written in that form. I know what a is, I know what h is, I know what k is. In this case, a is negative 4. So I know it's going to be upside down, and it's going to be skinnier. And then I know h is, now remember, it's negative 1. So it's going to shift to the left 1 unit. And k is 5. So it's going to shift up 5 units. Okay? So I could do that. I could graph it with the transformations. They don't ask us to graph this one. All right, so that's the process. You're going to see it again in the next 2 examples.